It's time to stop being afraid of coding. It's time to stop using no code or low code tools, because basically today you can build anything that you would like with natural language. Most of the people who are not using natural language with AI coding assistance, it's not statistically validated, but I believe it's because they are intimidated by coding and they believe that it is something that they cannot do. But the goal of this short presentation or course is kind of do a very broad overview of all the fundamentals of coding. This is a presentation that I've created based on a conversation that I had with a friend of mine. He is also a businessman and entrepreneur. And while he has a big team, he also likes to do stuff hands-on, automate stuff, especially when he feels that his team is underperforming or he believes that he can create bigger leverage with code. So we were going back and forth regarding what he should do. And initially he wanted to build automation using no-code tools such as N8N. By the way, I love no-code tools. I'm using N8N or Microsoft Power Automate desktop. I think it makes sense to use no-code tools in some cases, but as time goes by, it is going to make more and more sense to move away from these tools unless they build co-pilots, which are abilities to interact with the user interface verbally or with chat. So I'm suggesting moving away from these no-code tools and starting to build custom code. Before I dive into the outline of this course, let's call it a masterclass, I want to share with you that I've built a few funnels. I've built many funnels in my career, but I built a few funnels lately. So initially I built them with Elementor, which is a very famous no-code tool for building landing pages. But then I want to start tweaking it, and then I realized, okay, it's taking me a lot of time just to make the tweaks, change the blocks, change the headlines. Let's see if I can build this on my own. And I don't have any significant coding experience in terms of building web pages, but with combining V0, which is a tool for mostly building web apps, but mostly building a beautiful front end, and then asking a few questions, asking the chat a few questions regarding how can I deploy this web page. It actually took me 2 hours to build the whole landing page, copying a different landing page that I had, and eventually it looked better than what I built in Elementor. It loaded faster than what I built in Elementor, and it was also easier to build actually because I was just speaking with the AI. So this is just another instance of why I believe the world is moving towards custom code and not knowing how to code, while on one hand, most of the coding will probably be done by the agents or the LLMs. On the other hand, you still need to know the fundamentals and have like coding literacy to understand how things are working underneath the hood. Even if you're not planning to build code on your own, I believe that anything that you do as a business person, you should have at least a proficiency level that you are able to detect bullshit. So let's say if a great coder, an expert coder has 100% proficiency and someone who knows shit about coding has 0% proficiency, I believe that you should have like at least 50 or 60, just so you'll know the jargon. So let's say you hire someone to build something for you, you know what to ask, you know what guidelines you should tell them, restrictions, constraints. You know you need to be able to analyze the code at least in a high level to understand what's going on, because whenever I hired people in fields that I didn't know much about, very often it was very hard to assess if they are experts, if they know what they're doing, and it was even harder to give them criticism. So one alternative is hiring third party, like a consultant. But I believe that being able to build automations, build solutions, provide value to society is going to become easier and easier and more and become more important and impactful. So this is why I think everyone should study these fundamentals. Okay, that was a very long intro. Let's dive into the content. So basically we're going to cover, by the way, I have another screen here with a few notes. So basically we're going to cover different terms in coding. So what is pseudocode, what is HTML, what is API, what are JSONs, what is Python, Docker, stuff like this. Then we are going to learn about debugging, how to troubleshoot stuff, what is the best way to figure out what is wrong, a few frameworks or fundamentals, or maybe it would be more precise to say principles for coding. And these principles are very important for coding, but also for anything that you're building. So I was very actually inspired when I read a book which is called Clean Code. It discusses about how to write clean code, which is great code. Code was very, one of the benchmarks that he says over there is you want to minimize the amount of what the fucks per minute. So basically, if someone else reads your code, you want them to have as little what the fucks as possible per minute. So everything should be clear. And this also reminds me of a quote I had during the conversation that I had with a podcast guest of mine. Basically, we discussed SOPs, standard operating procedures, or how to provide guidance or instructions to your team members or colleagues. And I told him, okay, when I write an SOP, usually what I do, I try to write the SOP. Then I do a Vimeo screen recording or record with OBS, create a Google Doc with all the steps, with the link to the video, and then that's pretty much it. And then we iterate on this. And I try to make it as clear as possible. And then he corrected me and he said, an SOP or instructions, they shouldn't be as clear as possible. It should be impossible to get them wrong. So there is a huge difference, and he said, and I agree, there is a huge difference between something that is clear and something that is impossible to get wrong. So let's say I provided clear instructions. Okay, it's good, but some people can make mistakes. But on the other hand, if I provide instructions that are impossible to deviate from or make any errors or mistakes, this is how an SOP should be built. Okay, so this is regarding clean code and how important are the principles in clean code, and you can learn many takeaways from clean code to whatever that you're doing. Now, the first topic that I want to cover is understanding pseudocode. What basically pseudocode is just a plan, in plain language, a description of your code steps. So let's use an analogy for cooking. It's just writing a simple recipe outline before you begin the cooking. Or let's say an analogy from the marketing world. So drafting a rough campaign strategy before polishing your advertisement. So pseudocode is basically as if you took paper and you wrote down what exactly you want to do. I want to go to this website, scrape all the pricing, scrape all the headlines, and return everything into an Excel file. So this is the pseudocode. This is your plan. Now, every pseudocode contains different constructs, variables. So let's say these are the ingredients of your recipe. Conditions, basically these are mostly it's if. So these are deciding if your dish needs more salt based on taste. So for example, if I build a scraping automation, I want to go to a website, and then only if this specific image was uploaded, appeared on the screen, only then I want to scrape the price. So this is an if, this is a condition. Next, we have the loops. Loops is basically the number of iterations we want this whole code to do. So let's say I have 100 URLs that I want to scrape. So I'm going to need to have 100 loops of 100 loops of the same code. And as I said, the example is you gather ingredients, then you preheat the oven, then you mix and bake, and then you serve. This is just a pseudocode example. Then we have functions and procedures. So these are reusable steps, like pouring the ingredients. So this is an example from the cooking, but let's say you want to scrape the website, the specific page. So scraping the pricing, this is a specific function or an ingredient. Okay, so this is pseudocode, something that you need to know and be familiar with. Let's move onward. So now we have different developer tools in which we build code, and this is the one of the things that most people are very intimidated about. By the way, I didn't mention that in terms of background. I think it's important to understand that I used to learn coding when I was in high school. I learned coding for 3 years. Then I studied industrial engineering, in which during the degree, like it's a Bachelor of Science, we did some coding courses. And I consider myself technical, but I never really wrote code of big projects until AI emerged. But in the last 2 years, I've been building a lot of stuff, especially automations, but also web apps. So just to give you context, so everything that I'm sharing in this presentation is from the point of view of a marketer or a business person, not from a point of view of someone who studied coding his whole life. So I might have mistakes or stuff that are not accurate, but on the other hand, I want to share a high-level overview. This presentation isn't about the nuances; it's more like like the high-level stuff. That afterwards you can, first of all, you won't be intimidated to approach code, and afterwards you can decide into which rabbit hole you want to dive into in terms of coding. But I just want to do a very broad and shallow overview of all the jargon and all the stuff that I believe that one should know in order to decrease the anxiety and intimidation of approaching code. Okay, going back to the presentation. So developer tools overview. So basically we have the terminal, which is, it looks like this. Basically it's looks like this. Over here you can do different commands. So you have the command prompt. You have another terminal which is called PowerShell, for example. And you have another terminal that is called Bash, for example. Now, there are different nuances for each terminal, but it's just something that you need to know. This is one way of operating. And the other way of operating is using an IDE. An IDE, the most famous and popular one is Visual Studio Code. This is how it looks like. So basically, you can open a terminal like I showed you before, and you can also open a folder. And then you will see, let's open this folder. Let's say this, let's find folder that is relevant. So let's open this folder. As you can see here, we have all the folders, all the files. And this is the most popular IDE. Most of the people are using this. What you can do here is basically, I highly recommend, and I did a video about this, is that you learn how to use VS Code. In order to learn VS Code, you can either watch a tutorial or you can go to Google. Let me close this. Google AI Studio. And use the stream real time. Share your screen, and then you can just start asking questions and it will instruct you. So
Okay, so I'll ask you questions and that will guide you. Is that correct?
exactly. Can you explain to me about VS Code?
Sure, VS Code is a source code editor. It is a popular tool used by developers to write and manage code for various programming languages. Do you want to know anything specific about it?
Teach me specifically about the extensions.
Okay, VS Code extensions add extra features and tools to the editor. They can help with things like code completion, debugging, and more. What specific kind of extension would you like to learn about?
Never mind. What does this do?
Okay, the button you just clicked opens the source control view. This feature of Garos's code lets you manage changes in your code using Git. Would you like to know how to use that?
No, thank you.
Okay, no problem. Is there anything else you'd like to explore in Guada versus code?
Okay, so let's close this. And so I highly recommend using this free feature by Google, in which you stream real time and you share your screen, and then you can just, it's as if you have a private tutor over your shoulder and just asking questions. And the great thing about this is that you can ask any question that you would like. You don't have to be shy. You don't need to be afraid of asking stupid questions because it's just between you and the LLM. Okay, so we have the VS Code and we have the terminals. These are how, like, the environments in which code is being written. It is worth mentioning that in order to incorporate AI into the IDE, you have all different extensions such as Klein or Rucode, in which you can just type whatever you want and it's going to write the code for you and analyze the code base for you. Or you can download IDEs such as Windsurf, which, as you can see, looks like VS Code, but it already has AI baked into it. So let me open Windsurf over here. Now I can just ask it, please change the colors. Okay, never mind. Let's say, please write a web app for me to do list app in React. So I just asked it to write a web app for me, React, and it's going to create the folder, it's going to create all the files, it's going to create the README. This is eventually what I would like or suggest that you do, because as you can see here, you own like most of the stuff you need is curiosity and an ability to speak, because you can just go back and forth with the LLM, with natural language, and build whatever you want. And this is why I believe this is more powerful than just using a no-code or a low-code tool. So in a moment, it will create all the files and you will see all files here. And then we will start iterating and building the web app. By the way, this is using Claude 3.5 Sonnet. So, okay, so we covered the IDEs. Let's see if there is anything specific that I wanted to discuss about IDEs. No. So, okay, so now let's discuss common terminals. So we said we have Bash, we have command prompt, and we have the PowerShell. So basically the analogy that is proposed here by the chat, because when I created this course, I used chat to give me analogies from the cooking world and the marketing world, because these are kind of words that I'm familiar with and they're simple to understand. So different terminals is like having different types of stoves. You have like electric stove, you have the gas stove, and you have induction. They all serve the same purpose, but they have different features. Now let's discuss some command line fundamentals. So this is somewhat important. Yeah, it's somewhat important just to know the basics. So you have CD. Let's do like this. So CD basically changes the directory. So, and dir shows you all the directories available. So let's say I want to go into Dell. This is one of the directories available. So I do CD, change directory, Dell. And it is going, as you can see here, it opened up in Dell. Now I want to see all the files relevant here. So this is all the content of this directory. We have the make dir. Let's go do like this. We have the make dir, which basically allows you to create a directory. It's as if you're opening a new folder. These are the basics. You can find, you can ask ChatGPT. Let's ask ChatGPT. Can you create a cheat sheet for me in order to learn all the command lines, most important and most popular commands? So we can just create a cheat sheet. As you can see here, basic commands. We see the command in Windows and in Linux, list files in directory. So as I showed you, it's dir. Here it's ls. Change directory is cd in both. A remove file in Linux and Mac is going to be rm. In Windows is going to be del. So this is a cheat sheet which you can definitely create. Moving forward, let's discuss virtual environments and Anaconda. Let's see. Okay, we discussed this. Okay, virtual environments and Anaconda. So virtual environments basically isolate project dependencies of each project. You can, and now virtual environments and Anaconda are just different mechanisms in order to create a virtual environment. Let's see what exactly it says. Let's just paste it here. You know what? It's going to be faster and it's going to look better if we just come here. Let's do like this. Okay. So the analogy is basically separate kitchens for baking and savory dishes to prevent flavor mix-up. So you create an isolated virtual environment for each project in order to make sure that you don't mix between elements of each project. Dieting, so tailored meal plan for different goals. Now, in terms of creating a virtual environment, again, for this, you can use any LLM that you would like. You can also ask Windsurf. Let's close this for a second. Can you create a virtual environment for me? Call it YouTube tutorial. And it's just going to create the virtual environments for you, but it's important that you know what are virtual environments. So moving back here. So Anaconda is also a way to manage and simplify packages and environment management. This is something that you need to know. A lot of projects are using Anaconda. Now let's move forward to GitHub. So GitHub basically tracks changes in your code and it makes version management and collaboration easier. Now let's go to GitHub AG2. This is a project, agentic project by the AG2 team. This is their GitHub repository. GitHub basically has many open source projects. You can just look up whatever you would like here. Let's say you want to build an Instagram DM bot. You can write here IGDM bot. And you will see over here many different projects that already someone else built and they just open sourced or shared the code. You can sort by most stars, most forks, best match, whatever. Basically, most stars is the best indicator of the popularity of the project, but obviously you should also take into account the date, etc. Let's say I want trading bot. Let's see what are the alternatives. Okay, we have 19,000 different repositories, projects with a trading bot. Let's see what is the most popular one. This one is the most popular one. And this is how the repository looks like. Usually you have all the files and the folders. Then you have the README files in which you have data about the project, usually how to use it, how to install, the features, etc., as you can see here. Then you have all the issues. These are issues that people, contributors and people who are using the platform try to use this bot or raising, and you can go into each issue and read about it. This is especially useful if you're encountering bugs or mostly bugs whenever you're trying to build. So if you're not sure why things are not working out, you should go to the repository of the specific project and see if there's a known issue, because maybe it's not just something that you're doing wrong. Maybe there is something wrong with the code and there is a bug. So we have the issues, we have pull requests. These are basically people who build different features that can enhance the project, and basically they are requesting the builders of the code base to take a look and approve this pull request in order to merge it into the main code. You have GitHub Actions. Basically you can automate different workflows in the repository, and you have a few more things such as that we won't cover here. Not necessarily relevant. Now, a few things that you need to know about GitHub. So let's copy this. It will be easier and better. Okay. So GitHub basically offers a visual interface to manage repositories and collaborate with others. An analogy is from the cooking world, a shared digital cookbook where chefs contribute and refine recipes. Or for the marketing world, a central hub for collaborative campaign planning and review. Now, GitHub, why did it paste like I wanted it to paste? Okay, so basically GitHub has different apps that you can use. So you have GitHub Desktop, for example, that offers an ability to control your repository from your desktop. So you can commit. Commit basically is adding changes or new files to your repository. So this way, whenever you build something that you want to save, you can just upload it. Let me show you here an example. So over here we see all the commits, and what we can do is we can see a description of the commit, what files exactly changed, and we can also roll back to the version that we had before the commit, basically. So this way, whenever you start building a project, let's say you got to a milestone or a checkpoint that you like, so you commit the project to your GitHub, then you keep on optimizing and building it. As soon as you got to a point in which you're happy about, you can commit the update and the upgrade. But if it turns out that the upgrade wasn't good enough, you can always revert back to the previous version. So basically, this is why this is so powerful. Now, you can also create branches. So let's say the other day I built an automation. It was for scraping Instagram and sending DMs, and I was happy about the performance of the project. But I wanted to test something. I wanted to test sending the DMs based on the images of the people in their Instagram profile. Now, I didn't want it to be in the main project. I just wanted to see how it works. So what I created a branch, which is basically as if you're I started out with the main road. Let's say this is the main road is the IGDM automation. Now I wanted to test what happens if I take a left. Basically create a branch, and test if I can send DMs based on images. Let's see if ChatGPT can explain this better than I did. I'm sure it can. Can you now explain the concept of branching in a GitHub project? Give analogies from the world of cooking and the world of driving. I always like using these, asking it to give analogies, because then it's easier to understand. So branching in Git allows developers to create separate versions of a project to work on different features, bug fixes, or experiments without affecting the main code. This enables multiple developers to work in parallel and merge changes back into the main branch when ready. So you branch, and only when you're happy and you believe this should go into the main project, you do the merging. Now let's see the cooking analogy. So imagine you're cooking a new recipe. The main branch is your original recipe that works well and is always ready, and you're always ready to serve it. If you try a new variation, e.g. adding more spices or changing ingredients, You create a branch by preparing a separate dish in a different pot. If the new version turns out great, you merge it back into your main recipe. If it's a disaster, you discard the experiment. Pretty straightforward. Let's see the driving analogy. The main branch is your usual route from home to work. Tried and tested. If there's a road walk or you want to find a faster route, you branch off and take a different street. If the new route is better, you adopt it and make it your regular commute. Basically, this is the merge. And if it leads to a dead end, you simply return to the main road without affecting the original path. So this is important to understand. This is merging. Now, obviously, as I said, using GitHub is a rabbit hole. You need to learn all the capabilities and features available. There are a ton of them, but this is just a high level in order to understand. Now let's discuss Docker. What is Docker? So I have it written here. Docker is a bit more technical. I wasn't sure that I want to share it in this presentation, but I decided I should. So what is Docker? Docker basically allows you to run application in isolated containers, ensuring consistent performance across environments. Now, Docker, this is the website. It's more for, it's more advanced. You can download Docker Desktop. It looks like this. And basically, the cool thing about Docker is once you create a Docker image, it's supposed to work in all different environments. Let's see if I can also explain this better. Okay, let's see what was the example that they said over here. So Docker containers are like meal prep boxes. Each contains everything needed to recreate the dish perfectly, no matter where you are. Okay, this is a great analogy. So basically, Docker containers, you download them from the GitHub repository or from the or just from Docker. There is like a marketplace of all the containers, and they are designed to have all the ingredients, all the libraries, all the code necessary in order for it to work well, no matter which computer you're using. So the workflow is you create a Docker image using Docker files. Usually you just take the Docker file that is provided by the team who built the project. Okay, moving forward, package management. Package management is very straightforward. You just need to know that in order to install Python libraries, you use pip command. In order to install JavaScript packages, you use npm and npx. Let's see if there's anything important over here. No, not really, but you will encounter pip, npm and npx very often. These are just ways in order to tell your terminal that you want to install something specific. So let's see, pip. So if you want to read more about pip, you can just read it over here. Nothing complex, but I wanted to share this because you're going to encounter this thing, pip, if you're using Python projects, and npm and npx if you're building JavaScript related projects. Now, writing clean code. This is the next part. So basically, clean code, I just feel like it's better if I just come here and share it over here. So clean code is clear, simple, and maintainable, because what you want to do, you want to avoid a situation in which you just write code very fast, whether using AI or not. And then let's assume that after 2 weeks, you wrote the code, you didn't have any comments, you didn't give any descriptive names to the files, any descriptive name to the functions, because you just wanted to see if it works. So it worked, whether it worked, let's assume that it worked well. But after 2 months, you came to the project and you wanna use it again, or you wanna make modifications. Now, since you don't have any comments, you didn't use any descriptive names, you just wrote stuff very fast and very scrappy in order for it to work. Now, in order for you to make adjustments or understand what is going on, because 2 months has passed, you don't remember shit. So you're going to be wasting a lot of time. Never mind that if you outsource this code or send this code to a colleague or a friend of yours, they won't understand anything. So this is why it's very important to make sure that you are working based on the principles of clean code. So naming convention, use descriptive names, small and focused functions. So break tasks into manageable pieces as if you're building with Lego blocks. Adding commenting. So explain why behind your code. And this is stuff that is baked into the LLMs are going to write the commenting anyways. And refactoring. So continuously improving your code just as you refine a meal based on feedback. So you start with first iteration of your code, but then you get a few more ideas. So you add a few more things. So then the code becomes, let's say, a bit messy. So then you refactor, you isolate things, you organize things again. So always maintaining the code. It's like cleaning your room. So you clean your room once, and then you start using it again. You throw some clothes on the floor. You don't put your shoes in the cupboard, etc. But after a while, it makes sense to improve everything and reorganize everything, because if you don't make it a conscious effort to organize the code base all the time, it will just get too messy to a point that you won't understand what is going on. So refactoring is very important. Now, there are a few things that are important in terms of designing software, and these are all things that are pretty much baked in to the LLMs to an extent. Most often when the LLM is going to write code, it takes these things into consideration, but I still think that you should know this stuff. So let's use ChatGPT again. Now we just took this image, took a snapshot of the image, and let's ask it to explain. Can you explain the concept in the image? Explain as if I'm in 8th grade and give me analogies from the world of cooking. Okay. Interoperability. So it's hard to pronounce. So this means that different software systems should be able to work together, just like how different cuisines like Italian, Mexican, and Chinese can be combined to make fusion dishes. Example, you can put soy sauce Asian on French Western and it still works. So your code should be able to work in different scripts. So let's say I have a piece of code that it is supposed to scrape pricing from a product page. So it's one thing if I build that specific script in order to scrape only the specific page on Amazon. That's not good. I want to build a piece of code that no matter what is the URL in which I'm going to use the script, it will be able to scrape the pricing. So one time I'm going to scrape Amazon, the other time I want to scrape Shopify stores, I want to scrape their prices. So ideally, my code should be able to perform anywhere. Composability. This means you can mix and match small parts of the software to create new things. So let's say I have a specific loops that loops over all the URLs, so it enters all the 100 URLs that I want to scrape. And initially I wanted to scrape the pricing, but now I want to take all of these URLs and go to the contact us page and send them a message via the contact us. So I want the loop that goes over the whole 100 URLs to be able, I want to be able to take it and place it in the new piece of code that goes to the contact us page. So it should be composable, extensible. So this means you can add new features to software without breaking what already is there. So example, you want when you start with a basic cheese pizza, but later you add pepperoni, mushrooms, or extra cheese. In coding, let's say I have this loop, goes over 100 URLs, and it scrapes the pricing. Now let's assume that I want to add something. Besides scraping the pricing, I also want to subscribe to the newsletter in the footer. So I must be able to do this. My code must allow me to do this. Scalability. This means software should be able to handle more users or data without breaking. So it's not enough if I build a script that is only able to go over 100 loops. It should be very easy for me to also change these 100 URLs to 1000 URLs, and it should still work. So this is something important to understand, scalability. Now, modularity. Every piece of code should be able to work on its own. This means breaking software into small reusable pieces so you can change one thing without affecting everything. This is pretty straightforward. Now, there are many more principles like these. Please mention more principles like these. Now give me two analogies. One analogy from the world of coding. Let's assume that I'm building a project that is scraping different URLs, and another analogy from the kitchen. So there are many more analogies, but I don't want to go over all of them. I just want to show you. So we have reusability, we have maintainability, simplicity, separations of concerns. Don't repeat yourself, which means basically you never do anything twice. So if you've done one thing, you should basically don't repeat yourself. I'm not going even to repeat myself. Okay, here are analogies. I'm not going to go over this, but I also wanted to show you how you can also take these concepts and learn them on your own. Moving forward, debugging and troubleshooting. So basically, debugging and troubleshooting is a very important aspect because things will break. We have different types of errors. Let's see. Okay. I'm using Gamma here. It's very useful for generating presentations. I just pasted common error types. We have syntax errors. These are like grammar mistakes in the code. The code won't run. So for example, a misspelled variable. We have runtime errors. This happens while the code is running, often due to unexpected input. And we have logical errors in which the code runs but doesn't do what it's supposed to do. Now, there are different debugging techniques. You can go over the code line by line and also run the code, and then you see exactly when it breaks. Another alternative is just adding logs. So after each step, you make sure that you write to yourself that this step has been completed or what exactly happened in the specific steps. And bear in mind that Windsurf is going to add a lot of logs into your code anyway. But if necessary, if you encounter an error, you can always ask it, listen, let's add more logs in order for us to be able to analyze what has gone wrong. Then it might create a big log file, which you can just take the log file and just paste it over here in ChatGPT, and ChatGPT or even Windsurf or Claude or whatever, they will tell you what exactly you need to do. Moving forward, let's see. I think we will skip this. We will skip this as well. Let's skip this as well. I don't want to make this too long. Okay. So next, let's just briefly cover HTML, CSS, and JavaScript, because these are important concepts. Some people are afraid of these words. So let's just make sure we cover them. Let's create a new slide. Okay, so basically HTML is the structure of the web. It's your blueprint. It's the blueprint of your kitchens. It defines where everything goes. It's the skeleton of your landing page. CSS is how you style your content. So giving it font size, colors, etc. And JavaScript is adding an interactivity. So JavaScript is like the final garnish that delights and surprises your diner or the interactive element of an ad that engages the audiences. Now, libraries, these are pre-made pieces of code that can speed up the process of building a website. So instead of building the website from scratch, you can use libraries such as React that have already built all the boilerplate. Basically, a boilerplate is how a project looks like when it just is being started. So they already built the foundation for your project. Now let's see how CSS looks like and HTML. So this is also something that I wanted you to learn or see is the Chrome DevTools. Basically over here, you can see the whole HTML of this page. This is the HTML of this page, how it is built, how it it has different classes. You can see different text. So let's say module number 8, you can see here the text. You can actually change this. Let's write module, not necessarily. Sometimes you can change this and it will also appear in the front end. Let's see module 7. It was supposed to change it. Let's look over here. I think it changed it. Let's see. It was supposed to change it. Anyway, so you can see here all the HTML, which is basically how the website is built. By the way, for those of you who don't know, over here you can see the responsiveness, how the website is going to look in different resolutions. So let's say 100%, like this. Okay. So we have the skeleton and we have over here the CSS. So the exact font and the border width. You can see I'm changing the border over here and it is changing the border here. Let's change this box sizing. We can remove this, you saw, and it removed the element. So over here you have the styling. You can actually change colors, etc. So this is the CSS, this is the HTML, this is the CSS. They are all available for you to inspect over here. This is the Chrome DevTools. Chrome DevTools is also important because you can see whenever you click something, you can see what is going on in the console. And you can see also what is going on in terms of making API calls. Now, API calls is the next thing that I wanted to cover, APIs and JSONs. And I think this will be pretty much it. Let's see. Yes, this is going to be pretty much it. And after I cover this, I'm going to share with you like how I would approach this and a few ideas for learning this or practicing this. So APIs and JSONs. APIs basically allows different systems to communicate. So APIs are like restaurant menus that list available dishes and ordering methods. I don't like this enough. Can you please explain to an 8th grader what is API? Give analogies from coding and from the world of cooking. Make it as simple as possible to understand. So this is a very important concept, obviously, APIs. What is an API? An API is like a messenger that helps two different things talk to each other. It allows one program to ask another program for information or help, just like how you ask a waiter to bring you food at a restaurant. Now, tools such as make.com or Zapier or stuff like this, these are API connectors. They're basically, let's say you have a Shopify store and you want to send all the data of the buyers to a Google Sheet. Shopify is going to connect to the Google Sheet via API. So we have an analogy here. Let's say you are building a web scraper to get the latest news headlines. Instead of scraping, which is basically manually copying the data from your website, you can use API provided by the news website. I go to the news website, connect to the API and ask it, hey, give me the latest news. And the API of the news website responds with the latest news, and everything can be organized in a Google spreadsheet or whatever. So it's like calling a pizza delivery service. Instead of going to the restaurant, taking the pizza yourself and carrying it home, the API does the hard work for you. I think we don't need another analogy. So API saves a lot of time. You don't have to build everything yourself. It makes things easier because you can just connect to different softwares, and it helps different systems work together. So this is important to understand. Now explain what are JSONs, why they are relevant to APIs. Also explain a bit about the different types of API calls and the structure. Let's see, JSONs are without A. Okay, what is a JSON? JSON is a simple way to organize and share data between computers. Think of it as a universal format that APIs use to send and receive information. So this is a JSON, an example. We have the name. This is a dictionary. We have the name, John Doe, age 30, city, New York. So it's structured like a list that a computer can easily understand. How is JSON relevant to APIs? When you ask an API for something like the latest news, it usually sends back the answer in a JSON format because JSON is easy to read, lightweight, and supported by almost all programming languages. Now let's see example of API request and response. Let's say you ask a weather API for today's weather in New York. So you send a request. The request is going to be get API weather.com today, and these are the parameters: city, New York. The API is going to respond city, New York, temperature 22 degrees Celsius, and the condition is sunny. Now your program can parse this data. We can say only take the temperature and paste it in my website. We have different types of API calls, HTTP methods. We have the get, which is for retrieving data. An analogy from the cooking is checking the menu in the restaurant. We have post, which is sending new data. So, for example, placing an order for food. We have put, which is basically updating existing data. So asking the chef to add extra cheese to your pizza. And we have delete, which is basically removing data, canceling your food order. These are the most popular one, get and post. How is an API call structured? So you make an API request. It has three parts: the endpoint, what is the URL in which we are calling, for example, the API of recipes.com pizza, the method, which is, for example, can be get, post, etc., and the headers and the body, which is going to look like this. So final analogy, API calls and ordering food, we get this. Now let's go, for example, to OpenAI documentation, docs API. We have the API reference. Basically over here, they are going to instruct us exactly how to call the APIs, their API. So you can call using curl, or you can call via Python. Now we have this request. Let's ask ChatGPT to explain. Can you explain this request? And I'm actually happy that I'm doing stuff on the fly over here, because it also shows you how I'm learning and just reacting to stuff instead of just, you don't have to know everything. You just need to be curious. Like, I don't know, I would say a big chunk of the work of developers before using LLMs were just figuring out errors and figuring stuff on their own. And this is still part of the work, you know. So this is also important. This is why I'm happy that I'm also showing you. I didn't have this presentation all like perfect upfront because I wanted to show you how I learn stuff, how I ask questions, etc. So let's break down this curl request. So it is making an API call to OpenAI ChatGPT API to generate a response. What this command does, the command sends a post request to OpenAI API to generate a chat completion using GPT-4 mini model. So breaking down the command, curl HTTPS, this is basically the URL. This is the type of command line tool used to send HTTP requests. This is the endpoint where exactly the API generates the chat response. This is the content type. This is the header. The header tells the API that we are sending data in JSON format. This is the authorization. Basically, it's the OpenAI API key. So this is basically the password in which we tell them this is my user, just so you know. And then we have the data, basically. This is the payload. This is also called the payload. So the model, what is the message, says this is a test, and the temperature. So the model specifies which models we want to use. The message defines the conversation history. We have the roles, and we have the content, which is the actual text input, and we have the temperature, which controls how random or creative the response is. 0.0 is very predictable, always give the safest response, and 1 is more random and creative. What happens when this runs? The request is sent to OpenAI API. The OpenAI processes the request using the model, and the API responds with a JSON object, which is going to look like this. This is going to be the object, and we can pass the object in order just to take the content. How can we parse this JSON in order to get only the content? How can we parse this JSON? And it's going to write the code for us and plus instructions. To extract the content from the API response, you can use different methods using JQ, which is using the command line, or using Python, which is more popular, I guess. So we have the URL, we have the headers, we have the data, we have the response, and this is the parsing. Response JSON, content, response JSON, and this is basically the parsing part, and this is the printing. We basically output the content, which we saved over here. And you can, to be honest, you can ask Windsurf to parse the content. If you tell it exactly what you want it to do, it will do it. So you don't need to worry about this. Let me think. I think I covered everything. This was just a very broad presentation about the most fundamental jargon and things that I think that you should know in order to not be intimidated by custom code, because I believe, and I told it at the beginning, but we're summarizing, so I'm saying it again. I believe that from now on, the models are just going to improve, and all we have to do is being able to think critically, organize our thoughts, and speak with the models in plain English or whatever language you want to use. And from there on, the models are going to build the code for us. I believe that this is the best way also today in order to build automations, in order to build solutions. From my experience, if you know what you're doing, if you kind of know your way around, and this is accumulated after just going back and forth, trial and error, using custom code with natural language, with an AI coding assistant such as Windsurf, or using Rook code or Klein, is going to be the fastest and easiest way to build anything. Yeah, that's pretty much it. I hope you enjoyed this video. I hope you found it valuable. If you did, please leave a like, obviously subscribe, and leave your comments below. If you haven't checked out my newsletter, in which I share updates about AI automations and AI agents, please make sure to check out nofluff.online. Let me do a shameless plug. Let's open this. It will be better. Just open the website and show you exactly. Oh, the website is down. I'll take a look in a moment. No, there we go. No Fluff, basically your #1 resource about using data-driven automation and AI agents to help your business thrive. Just come here, join the newsletter. No fluff, only interesting stuff that I find. If I don't find anything, I just skip the week because, yeah, what's the point of spamming you guys? That's pretty much it for today. I hope you enjoyed this video. Until next time, keep on automating.